Okay, hello, good day. So again, I'm Engineer Ernesto Prudenciado Jr. and welcome to my channel. So we're going to discuss today the second part of mechanics. So that is dynamics. Okay, what is dynamics? By definition, this is a branch of mechanics that deals with bodies in motion. But there are two major topics that divide dynamics. So these are kinematics and kinetics. Okay, so what is kinematics? This is the geometry of motion. This term is used to define the motion of a particle or body without consideration of the forces causing the motion. While kinetics, the branch of mechanics that relates to force acting on the body on its mass and acceleration. So I will discuss that or explain that in much detail later on. Okay. So first, we have here kinematics and kinetics. Okay. So under this kinematics, we have also translation. Also rotation and plane motion. Okay. So I will discuss this. What is translation? So if you have here a body and it moves so point A to point B. Okay, since A and B move along a straight line, so this is called rectilinear translation. Okay, so if this body moves along a curved motion, so this is called a curvilinear translation. Okay, so one of the particular example of this is the projectile motion. Okay, so we will discuss the example later on. So next is rotation. So what is rotation? One of the particular example of rotation is you have a pulley. Okay, and if you analyze one particular portion of a pulley, for example here, okay, this particular point will move along a circular path, no? And this is called the rotation. Okay? While plane motion is the combination of translation and rotation. So one of the particular example here is the wheel of a car. Okay? The wheel of a car travels from point here up to here, no? So while the wheel is rotating, okay, if we will consider one particular point here, it will rotate along the perimeter of a wheel, which is circular. So while this particle is rotating along the perimeter of the wheel, which is circular in motion, the center of the wheel is also traveling from point A up to point B. Okay? So this is now a combination of rectilinear translation and a rotation. Okay? So that is the meaning of plane motion. Okay, so before I forget, I will insert the two topics under translation as we discussed. So this is now rectilinear and curvilinear. Okay, but under rectilinear, so we still have subtopics. Uniform velocity. Sometimes it's called constant velocity and constant acceleration and variable acceleration. So we will have an example all of this later on. Okay. And under curvilinear, we have the very famous projectile motion. Okay? So these are the subtopics under dynamics. Okay? So we will discuss each one of these as our session go along. Okay. Okay, so let's start with uniform velocity. This one. Okay. So a boat has a speed of 8 miles per hour in still water and attempts directly across a river with a current 3 miles per hour. What is the effective speed of the boat? Okay. So let's draw first. If we have this river, okay, and the boat will go across this river, okay, and if there's no current, okay, the boat will run at 8 miles per hour, okay. So he wished to get across the river, no, but the river has a current of this one. There's a current of 3 miles per hour, okay. So if we will put together all the forces, so if the boat is traveling with 8 miles per hour and the current is traveling with 3 miles per hour, so therefore the boat is passing through this path. Okay? And we can see now that this is a hypotenuse of a triangle. Okay? So we can draw now this one. Okay? And this hypotenuse is what the problem looking for. So the effective speed of the boat. Okay, so this is 3 mph or miles per hour and this is 8 mph. So by Pythagorean theorem, velocity effective is equals to square root of 8 squared plus 3 squared. Okay, so this is what? Using our calculator, 8 squared plus 3 squared equals square root answer. So that is 8.54. Okay, 8.54 mph. So this is the effective speed of the boat. Okay, so that is what? Letter B. Okay, ayos. It's very easy. Okay, so let's go to problem number 2. So what is the resultant velocity of the point of x component v sub x equals t cubed minus 1 and the y component v sub y equals t squared minus t at the time t equals to 4. Okay, so we have given t equals to 4 and v sub x, meaning the component of the velocity along x, is t cubed minus 1. So we can substitute right away the given value 4 so from this equation. So this is 4 cubed minus 1. So we have what? So we have 4 cubed minus 1. So that is 63. Okay. And v sub y, the component of the resultant velocity along y is t squared minus t. Okay. So this is what? 4 squared minus 4. So 4 squared is 16 minus 4, so 12. Okay. So finding the velocity now, we will use the Pythagorean theorem. So this is vx squared plus v sub y squared. So just substitute this. This is what? 63 squared plus 12 squared. So what is the result? Square root of 63 squared plus 12 squared. So we have now 64.1326. So that is letter C. Okay, this one. Okay, So very easy. So let's go to problem in our quiz 1. Okay. So two men, A and B, starting at the same point at a circumference of a circle, walk at the same rate of 60 meters per minute. If A walks towards a center and B walks along the circumference and the radius of the circle is 800 meters, find the distance between two men, A and B, at the end of 5 minutes. Okay? So we have here given T equals to 5 minutes. 5 minutes. Okay? So we will draw first the circle. So we have here a circle. No? So, okay. So circle. So A walks towards the center and B walks along the circumference and the radius of the circle is 800. Okay. So if we have here, this is the center of the circle, assuming. Okay, so if this is the starting point, no? So A walks along this path, okay, towards the center. And okay, B walks along this path, okay? So they start at the same point here. And let's solve for the distance walked by A and B at 5 minutes, okay? The velocity is given 60 meters per minute, okay? So this is the velocity. So we can compute now the distance, no? So given this formula, distance equals to velocity times time. So the velocity is 60 meters per minute multiplied by 5. T is given 5 minutes. 5 minutes. Okay. So this cancels out how much? So this becomes 300 meters. Okay. So this is the distance of A and B, no, from T equals to 0. So meaning A walk here. Since the radius is 800 given, 800 no? Around here, okay? So that is what? 300 meters. Okay, and also, this one, B, also 300 meters, okay? So, we know that this is 800, therefore this is 500, no? At this point, okay? The question is, find the distance between two men, A and B, at the end of 5 minutes. So, we will solve this one. Okay? So, we will solve this one, this distance. So, let's say Z. Okay? So, how to solve Z? That is the problem. Okay? Okay. But take a look, this triangle. And we can find this angle, theta. So, by what? We can solve theta using this formula. The arc length, no? So the formula is r theta in radian. Okay? So that is the formula of length of arc. Okay? So we know that our r is what? 800. Okay? And we know LA, the length of arc, is 300. Okay? And we have now here theta in radian. Okay? So theta in radian equals 300 over 800. Okay? Because this is in radian, we must convert this into degrees. So theta in degrees is equals to theta in radian, okay, multiplied by what? So what is the conversion? 2 pi 360. Okay? So therefore, theta in degrees, substitute 300 over 800 times 360 over 2 pi. So we can now solve the theta. So what is theta? So 300 divided by 800 times 360 divide 2 divide pi. Okay. So we have now theta equals 21.49 degrees. Okay? So we have now theta. So look at this figure. We have this triangle, no? Okay, we know that this is 500. And this is z. This is what we are looking for. This is theta. And what is this? This one is the radius of a circle. So that is 800. Okay. So we can use cosine law. What is the formula of cosine law? So first, the side that we are looking for, c squared equals a squared plus b squared minus 2ab cosine of included angle. Okay? So z squared equals, what is a? 800 squared plus b is 500 squared minus 2 times 800 times 500 cosine of what? 21.49. So we can solve z equals to plus 500 squared minus 2 times 800 times 500 times cosine of 21.49. Okay? So equals square root of answer. So that is what? 381.50 or 60. Okay? Meters. So that is the answer, no? The distance of A and B after 5 minutes. So the answer is within our choices. 381.60. So most probably it's C. Okay? So this is the answer.